Good morning, Spring One. Thank you so much for joining us. We're here at the beginner-friendly spring track. I hope you all enjoyed that wonderful keynote, getting our day started right. I'm excited for another great day here on this track with all of you. We have our first presenter coming up, presenting full steam ahead with R2DBC. Please, everyone, welcome Mark Paluch.
Thank you, Bob. I'm Mark. Great to meet you, everybody, here at Spring One. And I'm going to walk you through R2DBC. And if you've participated the last years with us at Spring One, then you probably might be already familiar with R2DBC. And for those who aren't, then this is exactly the right talk for you to learn where R2DBC comes from, what it stands for. And so let's get started. The first and foremost information, what does R2DBC mean? Well, it stands for Reactive Relational Database Connectivity. And it is our effort, our community effort to bring together reactive programming and SQL databases. A few words about me. I'm project lead of the Spring Data project. I'm contributing heavily to R2DBC. I'm maintaining the latest Redis driver, so probably you see also my shirt. So I'm really in love with Redis, but I also in love with all the other database technologies. And as you probably can tell, I'm in love with non-blocking technologies, non-blocking algorithms, since that's the area where I get the most fun of. If you want to follow me, then either go to Twitter or GitHub, simply type in my handle, and then you will find updates about all the projects and the work I do. Now, before we dig really into the matter, we probably need to discuss a bit what really reactive is and why this really matters to us. So reactive is a quite young field of technology. And it somehow all started with Microsoft Excel, but I'm not going to talk too much about that. I'm rather going to focus on the thing where we started really seeing reactive technologies emerging in software systems. And two things happened in 2009. Microsoft released the .NET Framework 4.0, and in the same year, Akka was released. And they tie a bit together, since Akka was the first time that the JVM has seen something like a reactive framework. You had that message-oriented pattern in there. But how does the .NET release play into that? Well, .NET shipped in their version something like an observer and a subscriber. And this was a foundation for everything that happened later on. Netflix at some point adopted that pattern for their services and shipped that as RxJava. And there were a couple of more iterations and more tools as the time went on, where the ecosystem grew. And nowadays we have a lot of integrations, a lot of libraries that integrate somehow in a reactive world, provide you with a runtime environment, with a programming model, and much more. One thing that we have learned out of that is that programming models have changed. We typically see in the typical enterprise application something that is written in an imperative style. And at some point, this imperative style becomes a bottleneck for efficiency and scalability. So how do you go about that? Well, the thing that you need to do there is that you have to change something in order to become more efficient with your application and to scale even more with the existing hardware that you have. And that's somehow a thing that plays together, because scalability is limited by a couple of factors. And one of them is the number of machines that you have. You can't have an infinite number of that, but rather what you want to have is gaining more efficiency out of existing hardware. So reactive applications and reactive programming is key to that scalability enablement. What we see is that with that change, or from imperative to reactive, that a lot of applications leave the typical path of that CRUD application where you have a small user base, but rather you have a large user base with a reactive application, and the reactive application changes its way how it processes data. Typically, reactive applications are working in a stream-oriented fashion. They rather get a push from a data event, from a data source, and they do not pull or pull for data so much as we tend to do in imperative style programming. Pulling for data has always been something that doesn't really feel well when working with pulling for data. In a reactive world, we get an active signal, an active notification from our data source. It can be an event, it can be a message, it can be a data stream, something like that, that comes into our application. And from there on, we take that signal and do something about that. Might it be transform it into something different and write it out to a sink, or start sending other messages or reacting to that message that we have received. Now, one question that arises from the programming model change is SQL still the right choice for reactive applications? And the answer for that pretty much depends on your use case. There is no global true or false for that question, right or wrong, but rather it depends on the scope and the thing that you are trying to achieve with your application. So to wrap it up about reactive programming, we are talking about high efficiency applications. The typical reactive application is not the one where you have a simple CRUD pattern and a handful of users. Instead, what you have is thousands or millions of concurrent users, millions of concurrent messages that are happening at the same time, while you try to capture and master all the volume that comes into your application without losing your head, essentially. The key enabler to do so is the use of non-blocking APIs. Back in imperative programming, blocking is the mode of operation. But with blocking, we keep threads busy, and threads are also a constraint for scalability. You can't have an infinite number of them. But non-blocking doesn't really mean that we are going asynchronous. In fact, staying on the same thread is the most efficient thing that you can ever do. Going async is something that is a necessity because you need to clear some thread in order to make room for other workload that comes in at the same time. Key differentiator between async and reactive is that we have backpressure control on our reactive pipeline, and that we have some sort of flow control, how much data we can process at a time. When it comes to persistence, because this talk is all about persistence, and we are a reactive programmer, then we have a broad choice of data source and integrations that we can connect with. There are a few like Kafka, MongoDB, Cassandra, Couchbase, Redis, and all of those scale really good because you can simply add yet another cluster node to your cluster arrangement. The truth, however, is that the majority of data is hosted in SQL databases, your Oracle, your DB2, MySQL, MariaDB, Postgres, SQL Server. And I guess there are plenty more that fit into that category that communicate over SQL and that follow some sort of relational and asset functionality constraints. However, there's the statement that there is no connectivity is not entirely true. So let's dig into that, what this asterisk is all about. Now, if we go into non-blocking SQL persistence, then we can observe a lot of integrations that have spun off individually in their own projects. The MySQL driver ships since quite a time an XDev API, which is sort of a document store API-ish. It communicates through completable futures, so you can start a job and register for the future callback. And once the future completes, then your application gets notified, and you can continue with the work that you have started. It's a vendor-specific API, so it has nothing in common with JDBC. There are other driver efforts, like the Vertex Postgres driver. It is built on top of Netty. It is very fast, but the way how you operate with that is in a callback style. So you have to perform nested callbacks, nested chaining, and this makes it quite difficult to come up with a clean encoding style without losing all the signals and events. See, once you lose a callback, then you might lose the access to the success and completion signal or to error signals. And this introduces another level of complexity to that API. And again, the Vertex Postgres driver has nothing in common with JDBC. There's another driver like the jasync or an NDBC driver and many, many more that have started experimenting with non-blocking SQL access. They have all in common that there is no common API, because every single endeavor has started with their own way of thinking and their own API design. So there's nothing there that we can pull into a single standard where something like a Spring library, a Juke library could build on top of in terms of an interchangeable driver. And this makes it really hard for those libraries to come up with support for non-blocking SQL persistence. You can do things about JDBC, but in a very, very limited way. You can put JDBC on the thread pool to make those calls to JDBC look like non-blocking. But what you really achieve with that is that you put the problem somewhere else. There's an abstraction around JDBC and RxJava, which is called RxJava JDBC, or I think even it is called RxJDBC, which does exactly that it decorates JDBC with observables, maybe single and all the types from RxJava. And you have optionally the chance to offload all that work to a thread pool. Now, while it looks from the reactive pipeline as if it was non-blocking, it effectively moves the work onto different threads, so you put the problem somewhere else instead of solving it. And this is because there's no magic thing that could turn blocking calls into non-blocking ones. Project Loom, maybe some of you have heard about that, is an effort in the JDK space to introduce virtual threads. Virtual threads can be blocked, and as soon as a virtual thread sees a blocking call, it goes into a sort of idle mode, and the underlying kernel thread is free to do other work. So effectively, with Project Loom, you get a non-blocking-like behavior. Currently, Project Loom isn't production ready, and we don't even know when it will be. So relying on Project Loom isn't an alternative that we can use in production right now. You can, however, put still JDBC on a thread pool and introduce proper queuing and capacity controls to somehow interact with your SQL database if you take the downsides into account. But this requires a lot of instrumentation and orchestration and trial and error, which makes it, again, complex too complex for everybody to be used. A couple of years ago, Oracle announced and introduced an effort which was called Asynchronous Database API, ADBA. The intention of that effort was to bring asynchronous programming to the database world based on futures. So ADBA brings exactly that, what we would need from a reactive perspective. Perhaps not exactly what we need, but like the 90%. Because a lot of calls, like obtaining a connection, emits exactly a single thing, right? The only thing that was missing there is a streaming capability that could be used from a reactive streams perspective. Eventually, the team introduced some ideas and ways how to tackle that. But at that time, the ADBA project was discontinued in favor of Project Loom. However, we have learned that the source and the team behind ADBA has picked up ideas that emerged in R2DBC, and that is exactly the reason why I'm going to switch to R2DBC right now. Given the lack that there was no standard API and no way and no perspective for us how to integrate with SQL databases from a reactive programming perspective, a small team started investigating on the possibilities how this could be achieved. And it was back then in 2017 when the idea of R2DBC was born. So you see, R2DBC itself is a young venture. And R2DBC is intended to be a standard API for reactive programming with SQL databases on the JVM, built from the ground up with reactive programming in mind. R2DBC is member of the Reactive Foundation, and I'm happy to announce that R2DBC has found its home there. The Reactive Foundation fosters open source growth for reactive-minded projects, and it is a vendor-neutral home where those projects can grow and emerge to something bigger. RSocket, you maybe already have heard about that, is already part of the Reactive Foundation, and now R2DBC has joined the Reactive Foundation as well. R2DBC started with a few design principles in mind. To keep things pretty straight and to have a reason why things are how they are. The team around R2DBC had made its learnings from JDBC, and JDBC is a pretty extensive and stable facility that helps us from the imperative side to connect with SQL databases. However, JDBC isn't perfect if you look at it from user perspective and from a driver vendor perspective. The first and foremost thing is JDBC is a blocking API. So what we would need in order to connect reactively to our databases is something that is non-blocking and reactive all the way down to the database. R2DBC embraces reactive types and patterns. It has a very low barrier to entry since it depends only on the Reactive Streams SPI and Java 8. You aren't required to pull in any kind of composition library, Spring, Scala, Kotlin, whatever. It is pure JVM code without further dependencies besides reactive streams. A core idea of R2DBC was to deduplicate driver efforts. And by this, I mean efforts that every single driver has to implement in order to provide functionality. An example for that is the parameter bind marker abstraction that we can find in JDBC. Every time when we try to define a parameter in JDBC, we have to use the question mark as placeholder to bind a parameter to that single position. What every JDBC driver has to do then is to scan the SQL statement and replace the question mark with a database native parameter bind marker. And so every single driver becomes suddenly a facility for parsing and rewriting SQL statements. We do not want to have driver vendors to take that burden. Instead, we want to use what the database provides us natively, so the SQL statements don't need to be rewritten once the statement is passed into R2DBC itself. R2DBC should also stay an open and documented specification. Therefore, you will find a lot of specification documentation around the SPI itself. And the SPI is intended to be a very minimal set of things that have to be implemented by a driver. Only those that differ from database to database should be implemented by a driver itself. So therefore, you find classes like a connection factory, connection, statement, result, and row as an abstraction in R2DBC with a very minimal set of operations. And this standard API is intended to enable more humane APIs, such as libraries like Spring, Juke, Flyway, Liquid-based test containers, to build on top of that API, SPI. So those libraries can consume services provided by R2DBC drivers and surfaced up to the user. The SPI isn't really intended for users to be used directly. You can, if you do wish to do so, but it's going to be a bit cumbersome if you have to do that over and over again in your application code. Let me show you how R2DBC is being used with a little bit of example code. It all starts with a connection factory, and you create a connection from a connection factory. Once the connection is done, we create a statement on that connection, execute it, and a statement can return one-to-many result objects. Once a result object is ready to be consumed, we hand in a mapping function into that result, and we consume a row and an optional row metadata. As a typical user, you probably know which SQL you put into your application, and you are probably not so much interested in metadata. But this API is intended for libraries, and libraries have to know about the metadata, the column names, types, and so on and so forth, in order to consume all those results. Now, let's take a look on what we have already today. R2DBC 08 is a stable GA release. And it is 08 because we decided during the course of developing R2DBC that we are not exactly sure whether we have reached API stability. Therefore, we decided to switch from version 1.0 to 0.8 to signal, okay, we want to create a first release. It will be probably stable and backwards compatible to 09 and 1.0, but we aren't entirely sure yet. And that's the reason why you see a 08 on the specification. R2DBC gives you end-to-end non-blocking database communication experience. And every time you communicate with the database, you enable or disable auto-commit, you start a transaction, you run a statement. Every time you get hold of a publisher that emits a completion signal, rows, or an error signal as a result of that operation. R2DBC incorporates already batching, so you can batch multiple statements together and group them in order to minimize the number of I/O round trips between your driver and the database. There's support for big binary objects and big character objects, blobs and CLOBs, that you can stream in your application instead of reserving all 2 GB heap to just load the blob from the database and then consume it. No, instead, you get a direct chance to consume the blob and the CLOB in consumable chunks that do not exhaust your entire memory. Drivers feature an extensive type conversion, so they can convert, for instance, between local date time and local date, these kind of things, or between numbers. You have the fully fledged support for transactional support, like save points, transactions, isolation levels. Some drivers leverage even database-specific features, such as the Postgres driver, which is integrated with the Postgres replication protocol, also known as logical decode. R2DBC drivers get discovered from the class path using the service loader mechanism. We have connection URLs to simply specify the connection endpoint through an URL. And the URL is standardized, and that's different to compared to JDBC, where every driver defines their own scheme. In R2DBC, you follow really the URL scheme, and then you know how to construct every single driver URL. And you get categorized exceptions, such as bad grammar exceptions, data integrity violation exceptions, transient, non-transient, resource exceptions, and the like. And That's again a learning that we took from JDBC that introduced these kind of exceptions later on. R2DBC doesn't stop at 08. The specification is made to evolve, but the direction is not entirely clear. And by that, I mean that we have a few things that we still want to introduce, but there are still things where we don't know and for sure whether they are needed in today's real-world applications or not. For instance, what we know is that we want to bring extended transaction specifications to R2DBC. And by this, I mean things like starting a transaction in read-only mode or with consistency guarantees. Google Spanner is one of the examples that allows you to specify something like a consistency timestamp, where you want to read the data and get full consistency for the price of having probably a bit older data. And these are things that can be communicated through an extended transaction specification. Or if you want to pin your transaction to a read-only node or a replica node, these are the type of use cases that can be achieved using extended transactions. We want to improve on in-out parameter bindings. Right now, we have only in-parameter bindings. And the parameter type, the database type, the actual one, is derived from the parameter value from binding value. Some databases make a difference between UTF-8 and localized character sets, for instance, Microsoft SQL Server. And in order to cater better for these cases, we want to be able to specify their actual parameter type or whether the parameter ought to be an out parameter. Which brings us pretty close to the stored procedures story. Initially, we anticipated nobody is using stored procedures. But we quickly realized there are still stored procedures in use. But what we also learned is that there is no strong demand for strong procedures. Every time we bring up that topic, there is very little demand, which is a signal for us that we probably will wait until we have a real good reason to specify how stored procedures are being consumed in a reactive world. We are happy to discuss that topic every time. And if you feel that you have a good use case for that, drop us a note on the GitHub repository of the R2DBC project. R2DBC, the next version of R2DBC is scheduled for next year. Whether that's going to be in 0.9 or 1.0 is still up to debate, and the team is actively discussing which direction we're going to take. If you are interested into that, then feel free to chime in. You can find R2DBC itself on the website R2dbcEntity. And if you just drop R2DBC into Google, then it will take you also to all the GitHub repositories. Which takes me to the R2DBC ecosystem. When we started with R2DBC, we didn't really envision where this all is going to go and to head. Today, we have a huge ecosystem that hosts R2DBC artifacts. There's a specification document, the SPI itself. We have an R2DBC proxy component that gives observability and insight aspects into R2DBC-based drivers. There's a connection pooling component. There are a lot of client implementations and there's a huge driver community. And if we blank out those artifacts that are maintained by the R2DBC core developers who initially started with R2DBC itself, then we see then that the number of community artifacts has already outgrown what the R2DBC team has came up with. There's an active client implementation for Query DSL, R2DBC Migrate, which is a counterpart of Flyway or Liquibase. There's a Kotlin client that I can't even pronounce. There's an integration into test containers. JHipster is picking up on R2DBC. On the driver side, Google Cloud Spanner came up with a driver implementation for R2DBC. There are 2 drivers for MySQL. There's a driver for MariaDB, Postgres, SAP HANA. And big news, Oracle has as well announced that they are working on an R2DBC driver. And the same goes for DB2. Now, drivers are great because they give you connectivity to your already existing database. On the other hand, you need also a client. And besides the already mentioned clients, there are more clients already in the works. There are efforts on MyBetis, JDBI, Juke, you name it. And if you want to see a client happen for the thing that you need, then go to those projects, vote for those tickets to be happen, leave a comment there. And after the presentation, I will upload the slides and you will have access to all the links inside of that presentation. So let's wrap up R2DBC and go over to the Spring side in a moment. Now, what R2DBC gives you, if you do all the math, is that it moves out the thread congestion out of your JVM. Not more, not less. So you are able to achieve more work with less threads. R2DBC doesn't change the law of physics, and it doesn't change how the databases are working internally. It follows the database protocols, and it has to adhere to all the ACID rules. Effectively, what you do is move all the work to inside of the database. And as you know, database connections can be sometimes expensive. And this as well applies to R2DBC. So if you are planning to use R2DBC in production, then you have to do proper benchmarking to make sure that you don't overload your database. Besides that, you get really a lot of that. You get non-blocking streaming. You get database feature support out of database drivers. And the non-blocking streaming is especially something interesting that we will see on the Spring side, because with the JDBC result set, well, yes, you can do streaming with that, but there's always this result set that holds all your data, and you don't have any further access to that when you're using mapping tools like Hibernate or MyBetis, but instead, all these tools provide you already with the objects. So let's take a look on the Spring side of R2DBC. Spring is a pretty good place to begin your R2DBC story, since we have made already the first steps. So you could say Spring loves R2DBC. We started as early as 2018 with the initial steps to check whether R2DBC has a place in the production world, whether it's a weird idea that needs to be discarded, or whether that's something where we can start building our applications on. And through the course of almost 2 years, we have accompanied the R2DBC development with Spring Data R2DBC. And Spring Data R2DBC was our experimentation ground to bring and to surface R2DBC features into the Spring world itself. A couple of years later, now 2020, we have made a lot of learnings. And one of these learnings is that R2DBC is a thing. R2DBC makes sense to be used. And so we migrated a lot of the core R2DBC support out of Spring Data into Spring Framework 5.3, which is scheduled for later this year. And this means that we will see also a lot of deprecations in Spring Data 1.2, Spring Data R2DBC 1.2. And those deprecations touch all these places that went into Spring Framework Core. It doesn't mean that we abandon all of these facilities. It just means that you should, when you are using Spring R2DBC and Spring Data R2DBC, rather use all the Spring Framework provided classes. And talking of which, let's see what Spring R2DBC provides. It's a new module in Spring Framework 5.3, and its central class, DatabaseClient, is the entry point for your application if you want to reactively integrate with a SQL database. It features named parameter support. It has a bind marker API. So Spring is doing the job of rewriting SQL and replacing named parameters with the actual native parameter bind markers. So you can plug in your own bind markers if you have a database that has an R2DBC driver, but there's no bind marker support in Spring yet. It features a reactive transaction manager, so you can participate in database transactions that span multiple calls. You can do it on an at service level, where you annotate particular methods with at transactional, or you can use the transactional operator to make a chain of database calls part of a transaction. It also ships with initialization support if you want to initialize your schema, that is creating the tables or importing initial data. A core concept to R2DBC is the connection factory. A connection factory can be an entry point to a driver, a connection pool, an observability facility like R2DBC proxy, or something different. What we have learned in over the past years that multi-tenancy is a requirement to several applications. And multi-tenancy can be modeled in different ways. One way of doing it is by routing connections to different databases or to different schemas. So Spring Framework ships with an abstract routing connection factory that has access to Project Reactor's context. And you can route different connection creation calls to different backing drivers. You can also leverage a built-in connection factory to integrate with a third-party dependency that isn't Spring aware, so that once Query DSL comes out as a stable version, then you can use directly Query DSL as part of your transactions without Query DSL being even aware that it is running in a Spring context. Let's take a brief look on how you would use the database client. Database client is being created by using a connection factory. That's essentially your driver or connection pool that is being handed into the database client. After that, you can use the Fluent API to run various SQL statements where you are in full control over the SQL statement. In this example, we are selecting data from person table by using a where clause and a name parameter age. So select all the people from the person table where age greater than name parameter age. We bind the value 24 to the age parameter. And this is handled by Spring for you. So you don't need to rewrite the query. Optionally, you can apply filter functions. And this is to alter settings on the actual R2DBC statement. So statement is a type specified by R2DBC. And this is useful if you want to tweak the fetch size or deal with auto-generated keys and the like. And lastly, you apply a mapping function that creates your result type. And in this case, we are obtaining the columns first name and last name from the R2DBC row. Now, if we revisit that statement from earlier, that R2DBC is a truly streaming database connectivity facility, then we will also see that this mapping function is passed down to the driver. So every time the driver receives a row, decodes the row, it applies this mapping function that we have specified here. So the driver emits us our person object, and we have a truly streaming experience. Spring is facilitating this streaming experience since there is nothing that would collect all the rows upfront and then apply mapping or await that the entire result set has arrived, but rather as rows stream into the driver, they are decoded and emitted through the resulting flux. Now that we have talked about the role of Spring R2DBC, let's take a closer look on Spring Data R2DBC. With the move of the core support into Spring Framework, we had to adjust the role of Spring Data R2DBC a bit and put it on a similar level where Spring Data JDBC is today. Spring Data JDBC builds on top of Spring JDBC. Spring Data R2DBC builds on top of Spring R2DBC. So you see, we are roughly on the same level, although the APIs and types used there are different, but the concepts are pretty similar. In R2DBC, your central class and central entry point is R2dbcEntity Operations. And this is pretty much the foundation for everything that is happening within Spring Data R2DBC. It gives you access to query and update objects that take property names and where you can specify the where clause, some update operations. Property names are mapped into column names, and the entity name is mapped into the table name. So you can have a pretty type-safe way how to work with these objects. And if you have an IDE that integrates with the R2DBC foundation, then you can even rename a property to something different, and the IDE will find all the places where you have referred to that property name and replace that for you. So you reduce the risk of diverging property names, column names, and the like. In order to fulfill its work, Spring Data R2DBC has to be dialect aware. And by this, I mean that dialects have to cover the gap between the individual ways how databases work and accept SQL statements. There are differences in like paging or how you express certain things like aliases. And therefore, we are required to integrate with a dialect that covers all these differences and that tells Spring Data R2DBC what to do. One thing that isn't part of Spring Data R2DBC is mapped relations. We are actively discussing that topic, but we do not have a sufficiently good answer to how to surface mapped relations, especially because entities in a reactive world, and especially all data structures in a reactive world, should be immutable. And there we run into difficulties when trying to materialize those objects. A quick look on how you would use the entity template. So all the entity template methods allow you to interact with things that you would normally do on a database, selecting data, inserting, updating. There's a Fluent API that allows you to specify the domain type. Optionally, you can specify a table name. You can specify a query and then select whether you want to receive all rows. The first one, whether you want to apply an exists or count projection. And that's totally up to you what you decide for doing. Let's take a closer look on the query itself. The query allows you a pretty extensive specification of the where clause. You can, if you like, use limit offset-based pagination, and this is then transferred into the actual SQL query. You can specify the sort order and many more parameters on the query object. And all this is a foundation for R2DBC repositories. R2DBC repositories work exactly as every other repository implementation themselves. You have query derivation. There is a possibility to even specify pagination details like find first 10, and you get a paginated query. You can specify pagination as an additional parameter. You can make use of the add query annotation if you want to take control over the generated SQL. And again, there you have even access to named parameters. You can use modifying queries to receive the completion signal or the number of affected rows and much, much more. And from there on, you simply use it in your application as gateway to your data. Before we come to an end, let's take a look on what's new in Spring Data R2DBC 1.2. And this is a version which will ship as well in later this year, probably October. And there we have support for entity callbacks. We have support for auditing, and entity callbacks is a prerequisite for auditing because entity callbacks allow pre-processing or post-processing an entity in a fully non-blocking way, before, after converting it into its database format, and before and after save. There's support for spell context extensions that have access to Project Reactor context. And what you can do with that is integrating with things like Spring Security to provide access to things like the principal. We have revised the way how enum values are passed down to the driver. The Postgres driver itself has a possibility to take a Java enum and represent that as a Postgres enum. So this change comes handy in that area. And we provide, through Spring Data Commons, an abstraction to repository metrics. And you can hook into that to consume repository metrics. Let's take a look on an example entity callback. Entity callbacks are single abstract method interfaces, so-called functional interfaces, that get called with the entity, and they return a publisher of that entity. And you can modify that existing entity or return even a new instance of that entity in your entity callback. And this is handy for a couple of things. Let me show an example for using the Postgres sequence feature. In this case, we have an entity whose ID is null. So probably we are going to insert that entity because Spring Data tries to determine, based on the presence or absence of the ID value, whether an object is null, whether an object is new, or whether that's an existing one. We can, if the ID is null, we go out to the database, generate and obtain a new value from the person sequence, and map that into our entity and return that entity back. And by doing that, we have achieved an auto-generation feature into our application. So what's next for Spring Data R2DBC? So we know there will be a version 2.0, and we will align Spring Data JDBC and Spring Data R2DBC closer to each other. And this means that both projects already built on top of Spring Data Relational, and we will bring those modules together in the Spring Data Relational module. So both components are maintained side by side. Right now, Spring Data R2DBC lives in its own repository, and this creates sometimes a bit of more maintenance effort. Besides that, the concepts are pretty similar between both modules, and we want to achieve feature parity at some point between these modules. But until we get there, we will have to walk a bit longer way to learn how we can achieve that by retaining scalability, efficiency, and all those things that drive R2DBC in Spring Data R2DBC. With all that being said, I appreciate all the time that you spent here staying with me in that talk. I hope this was useful for you, and I'm going to see you in a minute in the Q&A call, in the Q&A session, or drop us some questions on the Slack chat. Thanks, everybody, and see you in a minute.
Thank you so much, Mark. That was great. I love R2DBC. Hard to say, fun to say once you get it right. We're very happy that you were able to share that with our beginner-friendly crew here. If you have any more questions for Mark, please head on over to the Slack channel for Spring One, which there's a beginner-friendly section, and there'll be a Zoom link which will send you over to a Q&A. So if you have any more questions for Mark, please do that now. And then we have another presentation coming up 5 minutes past the hour with Arjen Poutsma, and we will be introducing ourselves to WebMVC. So we'll see you in about 10 minutes or so. Thanks so much.